X. So if lambda and V1 are given of the covariance matrix S, we want to find for S squared. Okay, what do we have as information? If I ask you here, what is the size of S? Yeah, what is the size of S?
2 attributes.
Is equals to the size of S squared, which is 2 by 2, thank you. Because n by n. Yes, it is the covariance matrix. So what we have again? We have S V1, what is it? Lambda V1, right? Because it's eigenvalue and eigenvector, by definition. What we want to find, the eigenvalue and eigenvector of S squared. First of all, do you have any idea? We don't have S, we don't have X. So first of all, we have to check with V1, right? Let's do it. S squared of V1 equals to what?
Lambda square of V1.
But of S, not for S squared.
Yeah.
So it will be here. S times V1, right? Yes? What is this one here? Lambda V1, thank you. Lambda is constant. Anything constant, we can take it outside, right? So what will be here? Lambda SV1. Again, what is SV1? What is it? Lambda 1 times lambda 1 times V1. So what is conclusion, please? Conclusion, this one is exactly this one. So they have the same eigenvector, but the eigenvalue became squared. Finish, done. So you see how to step by step, right? Good. Well, we have this one, and you want to find the eigenvalues. I try with V1. I don't have any other choice, right? So S squared, what is S squared? SS. S V1, what is it? Lambda. Same thing, right? Lambda is constant, take it outside. SV1, what is it? So what should be at the end? Lambda 1 squared V1. So conclusion, what we have? S squared, it is a matrix, times V1 is lambda squared V1. What is conclusion? This is my eigenvalue, and V1 is eigenvector. Lambda 1 you have, V1 you have, finish. Done. Yes? Try to do second one.
It doesn't have the same
Sorry?
eigenvalue. Square of
Yeah, here it is 3, so here it will be 9. So any vector, eigenvector still the same. Any eigenvalue, it became square. So if I do here, I can prove power 5 or 6, the same idea. It will be lambda to the power 5. Okay, second one. So what I did here, please, you have to think. What are the definitions? Thank you, Adnan. Thank you. So when we have the definitions, just apply the definition and try to do step by step. Let's do the second one together, but please try to follow me. Okay. What we have, they said we have lambda 2 and V2 of S. First of all, what is the size of S V1, V1T? Still 2 by 2, right? Because V is 2. Okay. I want to find this one. Let's try with the, I can try with V1, we try with V2. Let's try with the, which one you prefer? Let's try with V2. What should be here, please? S V2 minus V1, V1T, V2. Clear? Yes? Okay. What is the value of this one, please? V1 and V2 are orthogonal or not? Are orthogonal. Now V1 and V2. So it will be 0 because they are perpendicular, right? So what will be here? S V2. What is SV2? SV2 is eigenvalue, which will be lambda 2 V2. So at the end, what we have? they have the same eigenvector, V2, and they have the same eigen value. Yes? This is my matrix A, and this is my result. Can you do the same thing? Try to do the same thing, but with V1, please. Can you try? Do this, I'll give you 2 minutes. Remove V2, do V1, and see how you can do the calculation. What difficulty you will face, please let me know. Just apply orthogonal, it is unit vector, and so on. So here conclusion, lambda 2 and V2 are eigen value and eigenvector of S V1 V1 T. Okay, let's do the same thing but with V1, please. S V2 V2 here. I choose V1 or V2? No, V1 V1. And do V1, please. Let's try to calculate. Go. I give you +3 in the midterm if you do it correctly. You want to try or I solve it? Yeah, 2 minutes, please. Tell me what is the eigenvalue and eigenvector. Go slowly in calculation. So I give you a hint. What you do? You can do the distribution, right? Yes? Go. What we have about the eigenvectors? What we have as information? They are orthogonal and identity, which is unit vector. So what is this one here? We call it is 1 because it's a value.
Give me plus.
Do again. So?
It's not the opposite.
Hmm?
It would be the same.
Because what we have this times this is the unit, is the modulo square. And the modulo square is 1. So what will be next step? I give you another hint. So we have only +1. What will be here? Minus V1. What's in next? Sorry? Common factor. Yes. What will be common factor here? V1, right? What will be here? Next one is? Identity. Thank you so much. If you do 1, it's wrong. What is the size of the identity? The same size of S. 2 by 2, 2 by 2. Thank you. Excellent. Never put 1 in the matrix. So, I don't know before, sorry, I did not, here I make it more complex. No. What is V1 and S1? They are eigenvalue and eigenvectors.
It's lambda 1.
So what will be here?
It's lambda 1.
So give me what is the new eigenvalue. What is it?
Lambda 1 minus identity.
Lambda 1 minus I identity.
Sorry, I cannot, it's not identity. It's 1 in this case.
In this scenario, we
Yeah.
will get 1.
Because this is a vector and vector. Let me think. Okay, because I need the value, right?
Yeah.
If I do identity, okay, if you do lambda, what is lambda here?
Right.
Value. You cannot put I, صح? Here, the same nature, so he should be 1. So, what is the new eigenvalue?
Lambda minus.
Lambda 1.
So, they have V1 is eigenvector, lambda 1 minus 1 is eigenvalue. Okay? So you see how to work few things. Try to use the property of the eigenvalue. Because sometimes you have your data, you do certain transformations, for example like this, S minus here, shifting, whatever, and you want to find idea about the eigenvalue and eigenvectors. So what I use? I use only 2 informations here to solve this one. I use What does mean eigenvalue? And we know that V1 is always 1, and V1, V2 is always 0. Perpendicular and unit vector. I use only those three things, nothing else. Okay, let's go to 8. If you want to do the projection of x1 over x2, okay, what is the direction of the new projections, please? We have x1 and we do the projection on x2. Look, this is my x1, and I want to do a projection on x2. Yes or no? But what we did about the projection, we're always taking the unit one, right? What is the unit here? Vector.
It's a norm of x2.
Yes, exactly. So it's x2 just divided by the norm of x2. Thank you. As simple as. So what should be the projection here, please?
It will be x.
We take this one, x2 transpose times x1. This is the formula, right? Correct? So what will be at the end? It will be x2t times x1 divided by x2. But this one is the value, right or no? This is the distance here. This, the distance here, the distance is this one. Right?
Yeah.
Okay, but if you want to find the vector, what will be the vector here?
Multiplied by x.
Projection of x1 over x2, which will be the distance times the unit vector, right? Which is x2, x1 divided by x2 squared, which means the answer B is correct. So-
It's correct as
No,
well.
no, I see. Until now, B is correct. How about the others? Is x1, if x1 and x2 are parallel, do you think it's correct this one or not?
Yes.
If x1 and x2 are parallel, what is the projection? It's itself. Yes or no?
Yes.
Look here, when we have here x1 and we have here x2, this is the projection, right? But if you have something is similar, more closer, it becomes again closer, right? But if you have x1 and x2 on the same thing, the projection is itself. It's already, we cannot project, right? It's something. So A is correct, yes.
Should we multiply by x2?
We multiply by x2, where?
In denominator, we
Yeah,
will have the square.
in the last, yes, the last one.
Do you agree or not?
The last one,
In
yes.
denominator.
x2, x1, x2 here, power 2.
X2.
Yes, x2, yeah, x2. Because x2 is the one we project on. This is unit vector, is this one?
I mean, if you look at option choice B, x2 multiplied by x2.
The whole
The whole thing, but whole
is
is
multiplied by x2.
Yes, yeah, thank you so much. Yeah, this one, yeah, thanks. Yeah. So it will be, yes, it will be, this is a value, and this is here. Yes, so it can be, yeah, correct. Yeah, perfect. Value times the vector is correct. Just check the natures. So B and A both are correct. How about C?
If they are perpendicular, then.
Correct or not?
No. In this scenario, no.
correct.
A is correct, yeah. Because if there are two parallel, what is the projection of itself? It's still the same. There's no projection, right?
Projection could be 0 if they are perpendicular.
So it is correct. Because if you have two things perpendicular here, what is the projection of this on this one? Is 0.
0.
There's nothing, right? Because cosine 90 is 0.
Doctor, can we say that the projection is itself again?
What we say? Projection is?
Itself again.
No, it is the origin point, not itself. Itself is when it's parallel. A vector on parallel this one, the projection is itself. But when we have a if something is perpendicular, it became a dot. And not it is 0, a vector.
We can
Clear?
also say that x2, with which of the following, we can say that x2 if x1 and x2 are parallel.
But no, but with the question, I want to project x1 on x2.
On x2.
Yes. Yeah. So still x1. Because we want, no, you see, if you want to project x2 on x1, is x2. But if you want to project x1 on x2, is x1. You see what I mean? What is your base and what you want to project? Yeah.
I don't get
Yeah. Look here. This is x2 is parallel. This is x1 is parallel. Do the projection. It's it. Because vector here or here or here, the same thing. Because it should be the same direction.
It can be x2 if x1 and x2 are parallel, right?
The negative.
It can be also x2 if x1 is parallel to x2.
If the question is what is the projection of x2 over x1, it's different. It's up to the projection. So A, B, C are correct, right? D. D for sure is not correct because look, I want to do projection of x1 over x2. I'm sure it will be following the direction of x2. But here the direction is x1, is wrong. So we have A, B, C is correct.
If we said vector x2 over vector x1, then D will be
If we do the order, yeah, here the D is correct, thank you. The D is correct if we said what is the projection of x2 over x1. Yeah, thank you, yeah, correct.
Doctor, then we have to take transpose of x1.
Hmm?
In that case, we have to take transpose of x1.
Not of, here with vector, it is not transpose. Because value times transpose. Yeah. No. Because at the end it's vector at the end. It's just the question how you are answering. Which one is over which one?
So for A, if two vectors are parallel, if we multiply them, we get the same matrix?
No. When you do the projections.
projection is just placing.
It means we multiply them.
Okay, let's try apply x1 and x2 are parallel, right? What will be, we apply the formula B, right? We apply the formula B, right? What will be the formula B? What is x1 and x2? X1 times x2, dot product, what is it please? When they are parallel, what is cosine? You remember what is dot product? Okay, let me do this. Okay, look here please. x2 times x1 means is x1 dot product x2. What does it mean? x1 times x2 times cosine theta, right? Yes? If they are parallel, what is theta? 0. Cosine 0 is 1. You simplify everything, you will get x1.
Doctor, we can't say that D is right if we are doing the projection of x2 over x1 because we're going to have to switch.
No, it's the same thing. Look here, take B, swap 1 and 2, you find the same thing, right?
Yeah, but we have to make it x1 transpose x2.
Doesn't matter when you do the product. This time this, or this time this, the same thing.
Oh,
Yeah. Because the dot product, see dot product here, x1, x2 you can
makes
change.
sense. Okay, yeah.
Because at the end is value.
Yeah.
When the value to transpose itself is the same. Yeah, 9. Good question means the learning is increasing, right? We have to quantify the learning as the deep learning, right?
Yes.
No, honestly, even for me to prepare this one, it took me a lot of time, honestly. So you need to, it's like when you eat, you have time, you walk to get nice digestion. So the same idea. And a lot of idea is repeating again and again. So take note about every single idea, please. Okay, so we have the following covariance matrix of xt equals to this one. Okay, for example, what is the size of x here? Only x.
Size of it.
In terms of m and n. Yes, n by m, correct. Yeah. Because the transport, right? Okay, which of the following covariance matrix is correct? So at the end, I need to have m by n, one of the formula, right?
How did you know what is n here?
Look here, take x transpose. What is the size of x transpose here? M and n.
Yeah, but I don't know what is the size of x1. x1 itself, I don't know.
It's a vector. Of course, always we call number of features is m. Yeah. It just by calling number of features is m. We don't know 3 or 4. Yeah, and normal, yeah. So, do you think A is correct, B is correct, or both is correct, or both are wrong? There is C also. I call it there is small typos. Okay. So, let A. They said if this one equals to 0 and this one is the mean is 0. Remember what we did at the beginning? When the mean is 0, we don't need to center the data. It's already centered. So xt and x, do you think 1 out of n is correct times this? But the product of the matrix, I have to make sure that it's m by n. What do you think? Is correct or not? Yes, it's correct. Because the size of xt is mn. So m by n.
Doctor, what on n we put?
Okay. What is the size of xt, please? Okay. What is the size of xt? M and n. Do you okay with that?
Yes.
What is the size of x? M by n. Okay? So A is correct. B. B the same thing. The mean is 0. I do the transpose, still the same thing, doesn't matter, right? I just put the transpose of the both this equation and this equation. I put only the transpose. So B is correct. C. Now the mean is not 0. I have to make the data centered as 0. How we can make it centered as 0? We have to minus this one. Do you think this one is the mean, as we did? X is the vector. You multiply by 1, 1, 1, 1, as we did, remember? ABC. So is correct. Again. Yes, because this one, if you want to check it, it will be mean, n times, which is something that does correct. Second one, I put a transpose here. We go to transpose of this one, and the transpose of this one is xt, and 1n times this one is exactly 1, 1, 1. Same. So D is again is. Look here, please. If I give you this one here, 1, 1, 1 times 1, 1, 1. What is it, please? What is this one here, please?
3 by 3.
3 by 3.
So it will be all is. You can check it, right?
Yes.
So C is correct, D is correct, B is correct, A is correct. All of them is correct. Okay, different form you can write it. Okay, we are done here. Let's go this one quickly. X1 and X2 are independent. What is the Pearson correlation? 0. You can't do no need to calculation, right? If I give you linear relation, what is the Pearson correlation? -1 or 1. According to the slope. If the slope is positive or slope is negative. Okay. This one we did it many times, right? 1, 3, 4, 8, x. Find x. The mode should be equals to the mean.
I think
We did it, right?
I know, but once you said mode, you already gave us a clue. Like it's either 1 or 3 or 4 or 8.
Yeah,
It has to be one
we
of
have
these.
4 kids.
So there is 4 possibility. 1, 1, 3, or 4, or 8.
Yeah.
So which one is which one? No, there is 3 solutions.
Yeah.
There is 3 solutions.
3.
Okay? I want to do it. You can do it later on. Here, find cosine similarity between x1 and x2. Who can remind me about the cosine formula? So, cosine theta, what is it, please, here? Is it correct?
Transpose on the
Yes.
second one.
So,
Is the transpose on the second one?
yes. Here, the distance between x1 and x2, we have to define the norm, yes, correct. Yeah. x1 times x2 means it is like, if you want, it is like dot product over the norm of each one. Okay? So here, Can we do it on the first one? Look at the first one, case. They have the same dimension, right? It's easy to calculate. Second one, no. One is high dimension, one is small dimension. They don't have the same natures. How we can compare them, how we can do things. So we cannot apply it on the second one. Correct? They don't have the same nature. Two data set, one dimension 2, one dimension 50. You cannot do comparison, right? You can do concatenation, maybe.
But can you say that x1 is subset of y1?
It's better to there's no, they don't have the same nature, we don't compare them. Right? For example, matrix plus 2. Doesn't make sense? For sure there is something wrong, right? Yes? Speed plus distance. Do you think it makes sense? You remember in physics, when you add something or multiply something with the same natures, you cannot compare two things with the same different spaces. Okay, so it's easy, right? Okay, next one. 13. How to find the distance by using the Gaussian kernel. What is the definition of Gaussian kernel, please?
Is it exponential?
I think it's exponential minus the value x1 minus x2 squared Euclidean distance, right? Yes? So here, what is it here, please? By definition, okay? There's nothing to understand. It's just how we plot it. We want to find. Let's do the first of all distance between two things. Kernel between. If we check vector between x1 and x2. Okay. And what is this one here, please? Here, what is it, please? Here. This is mean phi of x1 times phi of x2, right? Always like this. This is what we have, right? So now, my question is they want to find, compute the cosine similarity between the two vectors, okay? Cosine, okay. What is cosine of this one, please? I have phi of x minus y and phi of y, right? So the cosine, what is it, please? Is phi, because it's vector, right? Divided by the norm of, and the norm of, clear? Yes? What is this one here, please? Is kernel of x minus 1 and y, right? Because remember, when we have this and this, okay? Divided by, what is the norm here? The norm, mean times itself, right? So it will be here, kernel y, y. Times, second one, kernel of x minus y and x minus y. Clear? So here, usually now we can do the calculations. Clear? If x1, look at, if I do x1, x1, what will be here, please? x1 and x1 mean 0. Exponential 0 is 1. So when they are the same, it's always 1, right? Because exponential 0. I have to calculate this one. What will be here, please? So the denominator is 1, done, right? How to calculate this one here, please? Exponential of, it was 0.2 time the distance between
x1 is x minus 1 minus
so it will be the distance of
x.
2x. So we have to calculate this one. How to calculate the distance here, please? X we have, y we have. What will be, please? Can you please find me this one? X minus y minus y equals to what, please? X is minus 1, 1, 0, 1, minus 1, right? And minus 2 times minus 2, 2, 0, 2, 0. What will be here, please? Minus 3, 3, 0, 3, minus 1, right? What will be the distance now? What will be the distance, please? exponential minus 0.2 square root of,
It's negative 3 minus 1 and then minus 1.
yeah, here, no, here is correct.
Plus
right?
3.
Minus 1?
Yeah, minus, yeah. Thank you. Let's do it in this way. Minus, thank you, yeah. So it will be here, yeah, you're right. Here it will be 1. Here is minus 1. This is 0. This is minus 1 and 1, right? So 1, 1, 2, 3, 4. So it will be exponential of minus 2.4. Yeah, thank you. Let me check 13 if there's a mistake or not. Yeah, okay, 0.4, correct. Yeah, 14, please. You have this matrix, I find eigenvalue and eigenvector.
The norm is square.
Hmm?
Exponential, the norm is square. You put it not square.
Yes, square, thank you, yeah, you are right, thank you. Yeah, thanks. So there's no here, yeah. Thank you so much, yeah. You are right. Even in the solution, I put square root, yeah. Thanks so much. So it will be here, 0.8, yeah, thanks. You are right. Yeah, please, here is Euclidean distance square, right? It's not, so there's no square. Thank you. Okay. 14. Find the eigenvalue, eigenvector for the covariance matrix, this one. So this is easy polynomial to calculate. Because 3 by 3, time to time, is very difficult to calculate the eigenvalue, but this is simplified. So how to find the eigenvalue, please? Determinant of sigma minus I, right? What will be here? 1 minus lambda, minus 1, 0. After? 0, 0, 1 minus lambda, 0, 0, 2 minus lambda. What is the determinant of this one?
Minus lambda.
Here, there is a lot of 0, right? So it's better to do plus, minus, plus. 0, 0 is gone. I need to calculate this one times only this determinant. So it will be here 1 minus lambda times the small determinant. And the small determinant is 1 minus lambda times, minus 1 minus lambda, 2 minus lambda. So how many lambda we have? Is 1 and 2. Okay? So you can do the calculation. 0, 0 is nothing. Do you know how to calculate the determinant 3 by 3?
Yes.
Okay,
So
can.
is it because the values are 0 in the lower level? It's just the multiplication of the diagonal of the matrix?
Yes, if all the triangle are 0, we do the multiplication of triangle. Yes, this is another shortcut. Thank you.
The principle is 2,
Hmm?
lambda 3.
Lambda? Sorry?
I'm asking.
Multiple, yes, is multiple. Lambda is we call the multiplicity of lambda is 2.
Doctor, these very colors clear from
Yeah.
diagram.
Yeah, because here the solution of this one 0. So we have 1, 1, 2. Correct? Because at the end what we want to find determinant equals to 0. This is your question, right?
No, she's saying the principle is 2 is lambda 3.
Yeah, it's 2, yeah, thank you. But here we are asking, let's just find eigenvalue and eigenvectors. Next, how to find eigen?
Doctor, these values can be derived from the diagram.
Yeah.
In every case, this will be in this.
If there is a general formula for the eigen, for determinant of 3 by 3, it will be difficult because at the end you will find polynomial of degree
So
3.
I think here, in this diagram, we see the diagram of this matrix. We can derive the eigenvalue directly without calculating.
Yes, without, you can. Yeah. But this one you have to make sure that upper or lower is 0, 0, the triangle. Otherwise you cannot apply. For example here, if you have, for example, here, if you have, for example, here 6, you can't apply the multiplication of diagonal. You have to apply it this way. Yeah.
Only low triangle is 0, like upper triangle can have values.
Yeah, doesn't matter. One of them. One of them.
Doctor, it's not easy to find the determinant if it's not triangular.
Yeah, it's not. It will be a polynomial of degree 3. I will not give it. Yeah. Yeah, yeah. But it will be something like this. Easy. Okay. How to find eigenvalue? How to find eigenvalue? I will do it only for one, as you do for the others, right? So it will be here, sigma v equals to 2v. I'll try to get v2, right? What will be the system here? This minus 2i times v2 is 0. So what does it mean here, please? Let's do the matrix here. What is the matrix here, please? Can you help me? 1 minus 2. It will be minus 1, 0, 0. After 0, 0, 0. And here we do 2. It will be minus 1. And here is 0, 0, right? So this one is multiplied by x, y, z. Should be equals to 0, 0, 0. How we can calculate this one? A system of equations? It will be minus x equals to 0, minus y equals to 0, and 0 equals to 0. So how about, so here, mean x is 0, y is 0, right? What is my vector v2? Is x, y, z, right? So this is 0, 0, I will remove them. 0, 0. So what does it mean here? I will take z common factor. It will be 0, 0, 1. So this is the eigenvector. And the mode, and it is unit vector. You do the same thing for lambda 1. Yeah, because at the end we need only the directions. So for z, it doesn't matter, yeah, any value. Because I need to get it only this one. Let's do it for the...
Doctor, n value you mean instead of 1 you can put any value?
No, you have to put 1. Because the eigenvector should be unit vector. That should be, the module is 1. You can put 2, 3, yeah, it's fine. The same direction, but it should be unit vector. Yeah.
What if we put below what, like 0.5?
Still wrong, because I need it, unit is 1. Directions. Unit vector. Let's do for the second one. If lambda equals to 1, what happened here? Let's do the calculation here, please. What will be here, please? 0. Ah, there's minus 1. I forget it, right?
Yes.
Yeah, there's minus 1. So it's wrong here, what I do. I didn't see it, yeah. So here is minus 1. What will be here, please? I'll do it again.
Minus 6, minus 4.
What will be here? Minus x minus y equals to 0. Minus y equals to the same thing, right? So at the end, it's x equals to y equals to 0. Doesn't change calculation, okay? Okay. So what will be here, please? 0, minus 1, 0, 0, 0, 0, 0, 0, and 1. Times x, y, z should be equals to 0. Can you help me please here? What will be here? Minus x equals to 0.
Y is equal to 0.
And z equals to?
1.
X equals 1, right? No, yeah, 1. Z. So what will be at the end? X, y, z equals to what, please? X is 0, this is 1, and this is y, right? Yes?
Actually, z equals 0.
Sorry?
Z equals 0.
Z equals
No, 1.
Y.
Y we don't have anything. 0 equals 0.
Minus y equals 0.
The equation.
First equation. First 9 minus y.
When we multiply the right in
Are you sure?
the last row.
Okay,
in the
let's do it again. The first one, minus x equals to 0 or not?
Yes.
Yes.
Minus y
Okay.
Minus y, minus y. Yeah. Okay, second, what is it? Last one is? Do you okay with that? Okay, so what will be here, please? Let's do it again. Here it will be x, here it will be 0, and this is 1. How to write this one as vectors?
So y is equal to 0. Z also equal to 0.
Sorry?
Z equals 0.
Because
The one here,
I
what is
divide
it?
them as a
This is
equation.
multiplying by
It's not-
1.
Ah, and it's 0, yeah, I'm tired. Yeah, you are right. You are right. So what should be here? X equals to 1, 0. So this is Eigen vector. Yeah. But here, why I found this one? Because this is not a symmetric matrix, okay? It is not symmetric. Yes? Clear?
Let's see how we're using this.
The greatest.
I know, this I do it for lambda 2, I didn't do it for lambda 1. No, if I ask you to compress, here I ask you only find the eigenvalue and eigenvectors.
First principle.
Yeah, okay, so no need to do this one, yeah. No need. You're right. So, last questions. Find the eigenvector, eigenvalue for this new matrix. We did it in the previous question 7, right? The same idea. The same idea. Yeah, same as question 7, nothing different.
Question, why x is 1?
Why x equals to?
1. My y equal to
I don't know. Look here. What I find here? Only on y and on z. You see? So here what I check? This is 0. This is 0. This is keep it itself.
but the y
Okay.
is-
Take x common factor. X common factor. 1, 0, 0. I just took it common factor. Nothing else. Because at the end I have to find a vector with should be the modulo is 1. You divide it by itself. X over x is 1. Okay, so it still have a lot. Let's do 15. Here, please. A box contains 2 coins. One regular coin, one is fake. The probability. So the regular mean is half-half, head or tail. The second one is both are head-head. Okay, 1. You pick a coin at random and toss it and get a head. What is the probability that it is the 2-headed coin? 1.
Is it half? Because we have,
I mean, is it the fake one, right?
yeah, we have 2 choices, so it's half.
You have 3 choices.
No, we have 2
Look here.
points.
Probability is
To choose from.
Regular and fake one, right? I select 1 here, right? I select 1 randomly and I toss it, right? So to select the fake one, or I can select the regular one. What is the probability? Half. Now, if I do the regular, I can get head or tail. The probability is half. If I get fake, what is the probability of head? Is 1. And the probability is 0. Is it clear? This is what we have as check. What is the question? You pick one randomly and toss it and gets. Okay, so the probability of the result is head, the giving information, conditional. What I'm looking for, what is the probability that the one picked is the fake one? So we apply the conditional probability. We did it at the beginning, right? Remember, right? We did revisions. We did probability or never? This one, conditional one.
No.
So what is the conditional probability is? Probability of fake intersection head over the probability of head. What is the probability of fake and head? What is it?
Fake is hard.
Probability of fake and head. It is one.
1.
Which is half times 1, which is divided by probability of head. What we have head? Two possibilities. This one or this one. So half times half is 1/4. 1/4 plus half. So at the end, you multiply by 4, you simplify to be 2 out of 3. So the probability is 2 out of 3. This is just, we did it at the beginning, just short question for you, okay? The last question, yes, it is true or false. Yes, it is true, it is canon one, okay? Because we have x and y that are together, that's all. Let's go back to one of the questions that to escape it. Yeah, this one here.
The previous question, second one.
Yeah, I'll do this one first. I'll come back to it. Okay. So this is comes to the Gaussian distribution in high dimension, dimension 2. I give you the point A, and the coordinate in the rotated references is 3 and 2. And we want to find Mahalanobis distance of A to the mean, yes or no, of the point data. I give you the eigenvalue of the 2, 1. You remember when we did the questions here? I give you the ellipse, link it to the covariance matrix. So what do you think here? What is the shape of the, not sure, what is the eigenvector of the covariance matrix here? Vector, what they are? One of the questions, I can't give you this space. I ask you please, can you find the eigenvectors? Yes, but what is the vector? Directions? Yes, exactly. So this will be the main one, right? This is V1. Because we have lambda 1. So this we call it V1, the biggest one, and this we call it V2. Yes or no? So if we change the PCA, we go to those new eigenvector, and we have the data will be on the 2 directions. The coordinate will be 3 and 2. Now we want to find the distance here. What is the definition of the distance? You remember? Mahalanobis distance. We did it at the beginning. What is it? It's this one, right? Only this one here. You remember, right? X minus mu and so on. Look at this. It will be x minus mu t sigma minus 1 minus. Okay? Let's try this one. This is my covariance matrix. What should be please? Should be V diagonal and V T or opposite. Okay. What is the inverse matrix, please? So this one will be here. The inverse matrix here, what will be here, please? Any idea? The inverse of this? The inverse of this? And the inverse of this. And we know that the inverse of this is Vt, same thing, right? If you multiply them, you're getting additive matrix. So what will be here, please? Here will be V, and here will be Vt. And the matrix, when it is diagonal, lambda 1, 0, 0, lambda 2, 0. If you do the inverse, what is the diagonal of the inverse, please? 1 over the eigenvector. Thank you. So what will be here? V, 1 over lambda 1, 0, 0, 1 over lambda 2, and V, T. Yes? I did not think. I just calculate what is PCA. What does it mean? I'm getting the inverse. Okay. I will go back now to re-inject everything what we did. X minus mu t. What we have here, please? V 1 over lambda 1, 0, 0, 1 over lambda 2 times V t times x minus mu, right? What is Vt? It is 2 eigenvectors, V1t and V2t. What is this one here? V1 and V2. Okay? Let's calculate this one here, please. What should be the value here, please? V1t times x minus mu, V2t times x minus mu. The same matrix here. What should be here, please? It's exactly the same thing like this one, just I need to do the transpose. V1t times x minus mu, V2t times x minus mu. Okay, so the questions here. What is this one here, please? What is this one here? This is the projections, look at the projection of my vectors on the V1. So what will be the value of this one is 3. What is the value of this one is? 2. Done. So now we can calculate easily, right? Let me do the calculation after I give you the geometric explanation. It's really nice.
In the question, they want the distance between
Between
the
the point A,
Is it triangle?
Okay, look it.
3 and 2, we have already the dimension.
if you are doing the Euclidean distance. But now I'm asking about Mahalanobis distance. Is this one? It's different. If you do the Euclidean, I totally agree with you. 3 square plus 2 square under square root Pythagoras and done. Yeah, but here no. Yeah. So what will be at the end? Who can tell me? So what will be here? It will be 3, 2 times 1 out of 4, 0, 0, 1 out of 1 times 3, 2. What is it, please? 3, 2 times 3 out of 4 and 2, one more 2. If I multiply here, it will be 9 out of 4 plus 2 square out of 1. This is distance. So it will be, no, sorry, 9. 9 out of 4 plus 4 out of 1. This is the distance. But look here, what does it mean here? Look here, as you told me, it's Pythagoras theorem. It's correct, but with small change. Look here, when you have 3, look here, 3. The variance is bigger, right? When its variance is bigger, means the point is most close to this point. It's like gravity is taking it more. So the distance will be divided by the Eigen value. Let me give you another idea to understand it. So this will be our next chapter. Look, for example, you have a data like this, right? Data like this here, and the data is here. The point, the middle is here. The point is here. Do you think it belongs to this? Let me do it another way, make it, yeah, this one. This is, do you think this data belongs to this one or belongs to this one?
Right.
Why? Because the variance is bigger, right? So it's like the gravity of this, the distance here, it will be divided by the Eigen value. Where Eigen value is the variance. You see the idea? So the same thing here. The 3 should be divided by the Eigen value, by Eigen value square.
But I thought because they are specifying in the question between the point A and the middle.
Yeah.
So they are in the middle of this is the middle.
Yes, in the middle.
So I thought
But here,
you need to follow that equation. You need to
no, look here. When we talk about distance, there is millions of distance. If we're talking about Euclidean, you are totally right. But if talking about Mahalanobis, just you need to normalize by the values. So this is Mahalanobis at the end. It's just when you have the distance here, you have to divide by the values. The distance here, the value. So what will be here? It will be 3 out of lambda 2 and 2 out of lambda 1. Now we can apply Pythagoras theorem. So this is the geometric explanations.
Can you explain where will the point go?
Here, when we do next class, will be classifications.
Mm-hmm.
This point is belong to this class or to this class. Even the middle point is here,
Yes.
still belong to this one, because the variance is too big. I can look at it. If you have a density like this, and another density here, it's very tight. And the point is here, it's more close to this one, but in classification, it most likely belongs to the big one.
so
It's like 2 planets. The more the planet is bigger, more the gravity is bigger. So it attacks you more. Yeah.
So
Yeah.
we are gonna calculate the distance between this point and the middle. That distribution should be less than.
Exactly. So you take this distance here, you take this distance here. Here you divide it by the variance, here you divide it by the variance, and now you can compare. Yeah. So more the variance is bigger, more it has more chance to attract more point to its space. Okay, so all the solution is here. So at the end is nice square of this. I will do this one, I will stop here. Try to think about this one. Who solved this correctly? Or tried? find the big value is lambda 1. So what is lambda 1? Lambda, the big one is lambda. Lambda 1 over lambda 2 should be equals to 3 out of 2. 3 out of 2, right? 3 out of. Okay, this is the eigenvalue, eigenvectors, explanations. Yeah, look here, please. Okay, look here. This is the circle, right? What is eigenvalue, eigenvector here?
So here the eigen, this is a normal space for me.
No, you have data in the red one. This is your data, right? Questions here. What is the eigenvector of your covariance matrix? So now, I don't want to do the calculation. I want to do in geometric way.
It's
No, let's do step by step. What is eigenvectors? So, the principal one is this one, right? You have the degree 30, you can find V1, right? What is it? Cosine and sine. Yeah. Okay, here, 2, this one. When we have in degree 2, when we have the vector, just flip it, put minus, you get the other one. Yes? Okay, let me get. When you have a vector like this, 2 and 1,
okay.
how to find the orthogonal to this vector 2 and 1? What is it?
Minus 1, minus 2.
2 and 1, it will be 1, 2, and you put minus somewhere, up or down. Yes. So if I get the main one, I can get the other one, right? Yes?
Can you give us
Orthogonal. Okay. Let me do it here. So this is what I'm trying to do, a geometric explanation of the PCA. Because if you understand the geometric, the calculation will be easy, honestly. Look here, please. If I give you a vector, this one, right? V1. What should be the V2, the eigenvectors? You flip beta and alpha and you put minus. Why? Do the dot product, minus alpha beta plus alpha beta is 0. So they are perpendicular. Okay? So when we have something like this means is V1 and this mean is V2, right? And here, the distance from this one over distance of this one is the ratio of the eigenvalue. Right? Because what does mean, okay, let's give explanation, geometry. What does mean this one here, please? A times V1 equals to 3 V1. What does mean this one, please? So give me any vector V1, it will be getting bigger 3 times. You see that? If I do, here for example, what we have, 2 and 1, let's for example 3. What is A V2 equals to 0.1 V2. So if you give me a vector this one, it will be small. You see the idea here? Something you do stretching in one side and you compress in the other side. So this is what does mean geometric way.
So how come lambda is 1 here from this?
Because look here, the ratio between the two, between bigger and the smallest, it is the same thing like the ratio, the biggest eigenvalue over the smallest eigenvalue. So here, lambda 2 is the bigger, lambda 1 is bigger, lambda 1 over lambda 2, lambda 1 over lambda 2 should be equals to 3 out of 2. The ratio. And here, lambda 2 is 1, lambda 2 is 1, so it will be lambda 1 is 3 out of 2. I find lambda, I find eigenvector. How to find the covariance matrix? Okay, I give you the eigenvector. I give you the eigenvalue. How to find the covariance matrix? I give you everything, right? What is the formula for the covariance matrix? V times D times VT. You have everything. No. So here, what is my matrix? This one here, what is it? Is V times diagonal times VT, right? We have V or not? What there are V here, please? What is V1 here? What is V here? Is V1 and V2. What is V1 here, please? What is this V1? Cosine 30, sine 30. Yeah, dog. What will be the other one? Just flip it and put minus or upper. This is V. What is D? 3 out of 2, 0, 0, 1. Done. So you have D, you have everything. You do a lambda. Look at the biggest lambda over the minimum lambda. It goes to 3 out of 2. The ratio.
Because the ratio of
Yeah, the biggest radius over the smallest radius. Okay, so this one at the. Okay, so what I do to prepare the midterm, I will take this exam, I just modify it and give it to you. So please try to understand most of the topics. I will upload the solutions today and you can check it. Any questions here, what we did? So the target is not to give you hard exams, it's to understand. So today, I just give you how to do a geometric explanation of the PCA. It helps you a lot. Okay?
What is not in the exam? SPD?
At the exam?
Yeah, what is not in the exam? LDA is not in the exam.
Huh?
SVD and
No. It's included until PCA kernel only. So after that, it's not included, yeah. And you will have 3 hours, okay? If you can find another one who do proctoring, you can do the midnight, I'm fine also. If you can find it.